Hello everyone, my name is Nima. Welcome back to our organic chemistry series where I'll be teaching you about certain organic chemistry topics and how to effectively approach them. So today we're going to be talking about organometallic compounds, and as the name suggests, these guys are combine organic compounds with metals, and their generalized formula is written like this: R connected to an M. And these metals could be any metals from the alkali earth metals, alkali metals, transition metals. So it could be like sodium, magnesium, lithium, zinc, oh, manganese, iron, doesn't really matter. Some examples of these could be, uh, I don't know, Li, could be vinyl lithium, could be ethyl magnesium bromide. Um, there are some more stable compounds such as ferrocene. It's written like this. But these are really just what they are. The main point that you're gonna basically see a lot in your classes is actually the reactions that these guys can go through. And what they can do is they can turn any carbonyl group or a bond that is weakly held into an alcohol. And what I mean is, could be actually understood first by looking at the nature of this bond. So we know that our metals are highly electropositive, which would make this guy electronegative. And what this does is that this bond can easily break off and the electrons can be donated back to the carbon. And this will lead us with an R minus. And if you guys remember, any minus or any species that has a negative charge to it could act as a nucleophile and attack an electropositive center. So let's say we have this nucleophile now, and we want to attack a positive species. And the best way that I could show this to you is by using an example. So let's say we have this guy right over here. And the reason I'm using magnesium bromide is that if you guys remember, magnesium has a +2 charge and needs basically two groups on either side that are negative, or not negative, just connected to it. So what this does is that this guy right over here could break off and the electrons can get passed on to this, and this could become a nucleophile. And let's say we want to react this guy with this guy right over here, which is known as formaldehyde. So let's look at the nature of this bond right over here. So we know that the carbon is connected to two hydrogens and to an oxygen. And if you guys remember, oxygens are highly electronegative. So that this means that this guy is going to have a partial negative charge and this carbon is going to have a positive charge. So what this can do is I'm going to go through the mechanism for it. These lone pairs can go and attack this guy. But if we were to do this, that means that this carbon is going to have five bonds now, which is going to surpass this octet rule. So what we can do is we can move the lone pairs of this pi bond and move it back to the oxygen. And this will give us this species here. And And if you guys remember, we still had magnesium bromide right over there. I'll highlight it for you guys right here, which is still in our test tube. When we're doing this reaction, you never lose anything. And this magnesium still has a plus charge, so this guy is going to be a spectator right over here, like this, to keep everything balanced. And usually what you guys are going to see is there's going to be a second step after we get this negative oxygen right over here, where they're going to react it with an acid. And if you guys remember from Gen Chem, acids can donate protons or hydrogens, whichever one you like to say. And we know that this negative charge can easily grab a proton. So I'm actually going to do it like this, so it's easier to visualize. This negative species goes and grabs this hydrogen, and this bond moves right here. So in return, we're going to get hydrogen connected to an OH now. And if I were to write this properly, be 1, 2, 3, and OH. So 1, 2, 3, 1, 2, 3 connected to an OH. So we have propanol right here. So if you guys ever see a species that is connected to a metal and is reacting with a carbonyl group, so in reality it's going to be like this guy, formaldehyde, they're usually going to write acid at the second step. And don't forget, we always need a solvent in our or for our reagent, so we're going to use diethyl ether here. So now let's do one more example. I'm going to actually take the same exact starting reactant, and I'm going to react it with ethylene oxide. Go ahead and pause the video and see if you can do it yourself. And I'll be going through the mechanism. So we know that we're going to get a nucleophilic species right here. And in this bond, both carbons here and here are connected to an oxygen. So they're equally electropositive, or have a partially positive charge. So you can attack this nucleophile to either side. Doesn't really matter. So we're going to attack this guy. That means this bond goes right here. And we're going to get O minus. Just going to double check my carbons. 1, 2, 3, 4. So we have another one. 1, 2, 3, 4. There we go. And I know we are reacting it with acid. So that means a proton is going to get added to that. Going to get 1, 2, 3, 4 OH. So this time we have butanol. And you might be asking, how do we acquire these compounds? And the best way is to start with an alkyl halide. So let's say in this example I have ethyl bromide. All I need to do is super simple. I just reacted with magnesium and diethyl ether. You just want a product solvent which means that there's no protons ready to be donated. So in here, we don't have any acidic protons, so you can also use tetrahydrofuran, also known as THF. Doesn't really matter. I'm just going to use diethyl ether because it's easier and cooler to write. And this guy's just going to give me this. So I'm going to do a harder example now, and let's see if you guys can do it before I actually finish it. Awesome. So let's do another example. This one's a little bit more challenging. But the first thing I want you guys to look at is going to be obviously our reactant. And we're going to try to figure out where the electropositive centers or the partial positive charges are located. And as you can see, we have a carbonyl group connected to another oxygen. So this is actually an ester functional group, which means that this guy is definitely going to have a positive charge to it. So, and now we're going to look at our reactant as well on the arrow to see what type of nucleophile could it give us. So we have ethyl lithium, and we know that it's going to give us this species right here. So I'm going to draw an arrow. Actually, my bad. Right here. So if this guy were to react, as you guys know, the first step is attacking the electropositive or the carbon that has the positive charge. So this is what's going to give us, if I were to draw an arrow, perfect. So now you might be wondering, okay, I have a negative charge. I can easily react this with this acid right over here, get an alcohol. But usually when we do have an ester, what actually ends up happening is this lone pair moves down here to make a double bond, and this group right here would actually be a perfect leaving group. So what happens is this bond breaks right here, and the electrons move on to the oxygen. So what we're going to end up having is I'm going to redraw this. Another ketone with no minus, and if you guys see, we have acid in our container or reaction mixture, so I'm just going to write an OH here. So now we have two puzzle pieces. And if you guys remember from our question, we have two equivalent of our organometallic compound, which I forgot to mention, these guys are known as Grignard reagents. So since we have two equivalents, that means that there's going to be another nucleophile in our reaction mixture which can go and attack this guy again, which will give us this species right here. But since we don't have any other leaving groups, it has to react with our acid now. So we're going to add acid to it. It's going to become OH. I'm going to write this ethyl here. So now we have this guy in our reaction mixture as our final product, and on the side, if you guys remember, we had our ethanol. But this would be your final answer. So that's basically what organometallic compounds are all about. You react them with a carbon that is having a partial positive charge, usually connected to an oxygen. If it's double bonded, it'll give you an alcohol. If it's single bonded, it'll also give you an alcohol. But it's only if you reacted with this guy right here. Let me know if you guys have any more questions. You can always put it in the comments, and I will see you guys in the next video. Thank you.